Okay, today we're going to be looking at writing electron configurations and drawing orbital diagrams using the s, p, and d orbitals. Okay, so the first thing we want to do is kind of do some definitions of electron configuration, some rules, and then we're just going to dive in. So the first thing let's start off with is electron configuration works as an address to identify where all electrons in an atom are located. So we can think of it like an address. The same way that you have an address at your house or the school has an address, electrons have an address also. And we build the electron configuration from the lowest energy level to the highest energy level. And I'm going to cross this out. There's a typo right here. Go ahead and fill in energy level. So from the lowest energy level to the highest energy level needed for that atom. And you'll see when we're looking at a periodic table, it's almost like reading a book when we're starting to fill in electron configuration. And electrons are added to the orbital shape. Orbital shapes in a specific order, which corresponds to the periodic table. So electrons are added to the orbital shapes in a specific order, which corresponds to the periodic table. And then we use orbital diagrams to help us with writing electron configurations. You can think of an orbital diagram like a map. Like if you were inviting someone over to your house and they said, oh, where do you live? Well, chances are you wouldn't draw them a map, right? You would just give them an address. Well, an orbital diagram is like a map, and an electron configuration is like an address, okay? So let's talk about some rules for electron configuration. An energy level is filled with electrons before going on to the next energy level, okay? So the first energy level gets full, and then the second energy level gets full, and then the third energy level gets full. And then an orbital shape is filled before going on to the next orbital shape. So what I mean is the S, P, D, and F. So that's what I mean right here, is S, P, D, and F. So those shapes get filled before you move on. Okay, and remember, S is for sphere, meaning it's shaped like a sphere and it can hold 2 electrons. P is for peanut because it's shaped kind of like an unshelled peanut. And there are 3 suborbitals in the X, the Y, and the Z orientations. And then D is for dime because it's 10. So you have 5 suborbitals. Each one can hold 2 for a total of 10. And then F is for funky or 14 because we get some funny looking shapes at the F orbital. And there are 7 suborbitals and each one can hold 2 for a total of 14, okay? Next part, if an orbital has more than one shape, meaning more than one suborbital, each suborbital is filled with 1 electron each before they get to a second electron, okay? This occurs because it is more stable for the electrons to spread out since they are all negative and they want to repel each other. Okay, let's talk about this for just a second. Do any of you have siblings at home? Do you share a room with that sibling? Would you want to share a room with a sibling? Absolutely not, right? Well, electrons feel the same way, okay? Electrons want their own room. So you can think of a suborbital like a room. So each electron wants to be in its own suborbital. It's not going to pair up and share until it has to, okay? And then how we write them is with electron spins. So we have an up spin and we have what's called a down spin. So an up spin electron, we write like this, which is a half arrow pointing up. And then we have what's called a down spin electron, which is a half arrow pointing down, okay? And we are representing the electrons with these half arrows in our orbital diagrams. Electrons will be up spin if they're by themselves. If they're paired up, you'll have 1 up spin and 1 down spin, and that's because they're both negative and they're trying to get as far away from each other as possible. And so they take on what's called a different spin, an up spin or down spin, in order to get as far away from each other as possible, okay? So now we're going to use a periodic table. in order to complete these orbital diagrams. The first thing I'm going to do is explain the shape and then look at the periodic table. So hydrogen is my element that we're going to work on first. And then I see a 1s, 2s, 2p. These are representing energy levels and orbital shapes. So the 1 is the first energy level. The s is that orbital shape. The 2 is the second energy level. S is the orbital shape. 2 is the second energy level. P is that orbital shape. Okay, so that's how we're laying this out. What you're going to end up seeing is that we write electron configurations just as if we're reading a book. Okay, so this is going to end up being our orbital diagram, and then we will write our electron configuration here. So let's start with hydrogen. Okay, so looking at the periodic table, I've got hydrogen in this first block. Okay, it's my very first element. So how many electrons does hydrogen have? 1, because it is in, its atomic number is 1, and we're all neutral atoms right now. So I've got 1 electron that needs a home. Now, how many energy levels does it have? 1, because it's in the first period or the first row. What block is this? S, P, D, or F that we colored? This is the S block. So I'm in the 1s block in the first position. And what I mean by that is looking from left to right. If I were to count 1, 2, 1, 2, 3, 4, 5, so on, we can think of those like positions as if we're reading a book. Okay, so what that means then for my orbital diagram is I have 1 electron that's going to need a home. It's in the first energy level in the s orbital, so I'm going to draw 1 upspin electron. And that's it. Hydrogen has 1 electron that needs a home. It is in the first energy level. So if we think of this like floors of a building, and the S, the P, and the D are apartments on those floors, we fill up the first floor first before we move to the second one. Okay, so it only has 1 electron that needs a home. So if I'm writing the address for this, this was like a map that I drew. So now I'm going to write an address. I'd say 1s, my first energy level, my s orbital. How many electrons live there? How many did I draw? 1, 1s, 1. So that 1 in the exponent position is saying there's 1 electron that lives there. That's it. That's the map. This is the map, and then this is the address, 1s1. That is the electron configuration for a neutral atom of hydrogen. Okay, and that was here, 1s block in the first position. Now let's do helium. Helium, let's pick a different color. Let's do orange. Here is helium. How many electrons does it have? 2. So on my paper, I'm going to write 2e. 2e minus to tell me that there are 2 electrons that need homes. What energy level is it in? It's in the first energy level, and remember we colored this one special, right? So what block is this actually for helium? The S block. So we are in the first energy level in the S block because helium, yes, it's over here, but it is still part of the S block. In the second position, and I have 2 electrons that need homes. So the 1s orbital, I fill it up with a 1 going in upspin just like I did for hydrogen, but I can't move on to the 2s until the 1s is full, which means that I have to pair them up now. So if I pair them up, one is an upspin and the other is a downspin because they're trying to get as far away from each other in the same orbital. Okay, do all the electrons have homes now? Yes, so if I'm going to write this out, I would say 1s2, because in the first energy level, in the s orbital, there are 2 electrons that live there. So helium's electron configuration is 1s2. First energy level, s orbital, 2 electrons live there. Okay? All right, let's just keep going here. Lithium. Now I want to point something out here. Lithium, is that in the first energy level? No, it's in the second energy level. So if I were to think about this like reading a book, okay, I would read the entire first line before I got to the second line, correct?
Yeah.
Same idea, okay? Now, lithium, a neutral atom of lithium, all of our atoms are neutral today, has 3 electrons that's going to need homes, okay? Meaning we need to put them in orbitals. Well, if I read this like a book, my first energy level is full, and now I'm in my second energy level, and what block is over here? What letter? The S block. So I'm in my second energy level in the S block in first position. So 3 electrons, my S orbital for my first energy level is full. 1s is full. And then in my 2s, how many electrons are left that still need somewhere to live? Just 1, so I draw an upspin. Okay, so this is a map. If I turn this into an address, I would say 1s2, meaning my first energy level S orbital is full with 2, and then 2s1, because now my second energy level S orbital has 1 in it. It's almost like it's an apartment building and you're telling me how many people live on each floor in each apartment of that apartment building. Okay, let's keep moving. Let's look at boron. So boron now is over here. What energy level is boron? 2. And what block is this? P. So now I'm in the P block. Okay, so again, if I think of this like reading a book, I start at the first line and read from left to right, top to bottom. So my first energy level is full. My 2s energy is full. And now I'm at 2p in the first position because it's the first one of that row. And I've got 5 electrons that are going to need homes in this neutral atom of boron. So now I'm just going to fill them up the same way I did before. My first energy level is full, so my 1s orbital is full, 1 up, 1 down. Am I done? No. How many more electrons need homes? 3. So then in my 2s is full, 1 up, 1 down. First energy level is full. Second 2s energy level is full. Now I'm in 2p. How many still need a home? 1. So in my 2p, do you see how they're blank, blank, blank? So each one of those blanks is representing a suborbital. So we're saying the 2p in the x, the 2p in the y, and the 2p in the z. And each one of those can hold 2. So I have 1 electron left for boron. So I'm just going to draw a 1 up, and that's it. So now 1, 2, 3, 4, 5. 5 electrons have homes. Also, I ended in my 2p1 position, and everything else before it is full. So if I write this out, this is my map. I need an address. I would say 1s2, because my 1s orbital is full. 2s2, because my 2s orbital is full. 2p1, because there's only 1 electron in that 2p orbital. All right, let's look at another one. Here we go. Let's look at oxygen now. Oxygen is number 8, right here. So how many electrons are we going to put in homes? 8. Okay, so again, it's like reading a book. If I were to read this book, the 1s orbital is full, the 2s orbital is full, and the 2p orbital, 2p orbital has electrons in it, and oxygen is in the 1, 2, 3, 4th position. Okay, so think about that. We're ending in the 2p4 position. I want you to remember that to see when we end our electron configuration where we're at. So the 1s orbital is full, so 1 up, 1 down. The 2s orbital is full, 1 up, 1 down. But now let's talk about how we're going to fill this in. How many more electrons still need homes? 4. Okay, remember, you don't want to share a room with your sibling, just like electrons don't want to share suborbitals. Okay, so because they don't want to share suborbitals, we fill in 1 in each of those suborbitals first before we make them pair up. So I've got 3 suborbitals and 4 electrons left. So one up, one up, one up. I can separate them all into their own suborbital, but are we done? No. How many more electrons are left? One, which means, unfortunately, one of them has to pair up. So this first one, I'm going to draw a downspin because one of the suborbitals has a pair. So if I were to write this, the orbital diagram is a map, and now I'm going to write it as an address. 1s2, 2s2, 2p. How many are in this one? 4. Oh, hey, didn't we say that we ended in the 2p4 position? Maybe there's a trick here. All right, let's look at neon. Let's look at neon. I want you to take a second and try neon on your own first. All right, let's go ahead and go over neon. So I'm going to use purple for neon. Over here at the end, how many electrons need homes? 10 electrons. So if I'm reading this like a book, my 1s orbital is full, my 2s orbital is full, my 3s orbital, or excuse me, 3p orbital, oh my gosh, start over, 2p orbital is full. Okay, and what are we ending our position at? 2p6. So keep that in your mind. So for our diagram here, the 1s is full, so one up, one down. The 2s is full, one up, one down. 2p, I still have 6 electrons that need homes. So I'm going to fill it in and up, up, up. Are we done? Do they all get paired up? Sure do. Down, down, down. So can you use your chemistry robot voice and read to me what the electron configuration is? Yep, 1s2, then what? 2s2, and then? Perfect. Thumbs up if you got that. Okay, let's keep going. So let's look at magnesium. Magnesium is down here, number 12. How many electrons do we have that we need to put in homes? Same as 12. Where are we ending? What energy level? 3. What block? S. What position? 2. So we're ending in the 3s2, which means that everything before it is full. Okay, so that means my 1s, one up, one down. 2s, one up, one down. That's full. That's only 4. We have 8 to go. My 2p is full. One up, 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 down, down, down. That's 10. So how many are left? 2. So I have to fill up my 3s, and that's an up and a down. Oh, hey, didn't we say that we're ending in the 3s2 position? So using your chemistry robot voice, say out loud and tell me out loud, what is the electron configuration? Good. 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 3s2. Perfect. Okay, let's keep going. We're just doing a ton of examples to make sure we got this down before we get to the D block. Okay. Sulfur is over here. Number 16, which means I have 16 electrons that need homes. Where are we ending? 3. What block? P. What position? 1, 2, 3, 4. So we're ending at 3p4, which means that everything else before it is full. So 1 up, 1 down, 1 up, 1 down. My 1s, my 2s, that's 4. 12 to go. And up, 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 down, down, down. That's 10. So I have 6 electrons left. So what happens in the 3s? Good. And up and down. That's 2 more. So I have 4 left. Okay, there's 4 electrons, but I have 3 suborbitals. How are we going to fill this up? Do they want to share? No, they surely do not. So, and up, and up, and up. Are we done? Nope. 1 more has to pair up, right? So then that's going to be a down. So if I write this out, say out loud, like you mean it, What is the electron configuration? Keep going. 2s2, 2p6, 3s2, 3p4. Oh, look, there it is again. We ended in the 3p4 position, which means everything before it is full. Okay, now let's take a little pause here, and we need to look at the d orbital, because that's what's next. Okay, so because of the d orbital and trying to be stable and thinking about charges, the way that the d block fills in your orbitals is that it shoves it into a lower energy level. So yes, if I'm looking at this section right here, my d section of my periodic table, the d block, it's going to take those electrons and shove them in a lower energy level because it's trying to be more stable. It's trying to lower its energy. So one kind of tricky thing here is at this fourth energy level, yes, we have 4s. That is 4s like we're used to. But as soon as we get to the d block, it takes those electrons and shoves it into a lower energy level. So this is actually called 3d. So this row is 3d. The next row is 4d, 5d, and 6d. And this has to do with nuclear charge, and this has to do with a couple other things. But that's why we say, oh, the d block is the one to blame. The d block is funny. And that's because it's taking its electrons and moving it into the d orbital in a lower energy level. So when you're writing electron configurations, you write them like we have been, right? All the way over here to the 3p6, 4s2, and then we say 3d something. It just lowers that energy level by 1. And that's just something that we have to learn, okay? So if we're looking at manganese then, Mn is manganese. Mn is manganese. Let's do pink. It's right here. So I'm in the D block. I'm in the D block, which I know lowers it by 1. So I'm really in the 3D orbital in the 1, 2, 3, 4, 5th position. So I'm ending at 3D5. I've got 25 electrons that need homes. And that means that anything before this is full. So if I'm reading a book, and I know I used pink already, but I'm just going to use it again. The 1s is full, 2s is full, 2p is full, 3s is full, 3p is full, 4s is full, and now I'm in the 3d. Okay? So let's fill in our electrons like we've done before. 1 up, 1 down, 1 up, 1 down. I know this is all full because I can read my periodic table like a book. And I'm filling them in the proper way. That gets me to 18. So right now I have 18 electrons drawn. My 4s is full. The 4s is full, so that's an up and a down. That's 20 electrons. And now I have 5 more. Well, the same way that we filled up the P is the same way we're going to fill up the D, which means, do they want to share? No, they surely do not. So in each one of these suborbitals for D, I'm just going to draw a 1 upspin electron, which is just like what we've done before, but it is in the d orbital, which is down by 1 energy level. So if I write this out, I'm going to write it out the same way that I have before. Okay, all the way to 3p6. And now I just continue writing in order of how I filled the electrons. 4s2, 3d5. We are not going to move and switch these two. We're going to leave it based on how we filled it, like you read a book. Okay. okay? All right, so I want you to try the next one. Try arsenic on your own, and then we'll go over it. Okay, so let's look at arsenic. So arsenic is down here, number 33. So that means we have 33 electrons. What position are we ending in? Well, we're in the fourth energy level. Fourth energy level in the P block, in the 1, 2, 3, third position, okay? So that means everything else before it is full. So 1 up, down, 2s, 2p, that gets me to 10 electrons. So I've got 23 to go. 3s is full. 3p is full. That gets me to 18 electrons. The 4s is full. Now remember, as I'm reading this book, my 3D orbital ends up being full because it's on the other side in the P block. So 10 electrons there. So that gets me to 30. So I have 3 left. It's not going to want to share. So 1 upspin electron in each of the suborbitals. So in your chemistry robot voice, all at once, can you please tell me what the electron configuration is? 3p6, 4s2, what? 3d10, 4p3. There it is. Thumbs up if you got that right. Brilliant. Okay, that's electron configuration using the s, the p, and the d orbitals.